What happens if we take a strip of paper, join the ends together, and then cut it down the middle? Well, it splits apart, obviously, right? Now, what if we do the same thing, but we give it a small 180-degree twist on one of the ends? What happens if we cut it down the middle now? Well, obviously it splits apart again, right? But instead it turns into an even bigger loop. How's that possible? Now, what if we cut out 1/3 of the way down instead? What the hell?
Is this magic? Is this a camera trick? No, it's simply mathematics. This object falls under the branch of math called topology, which studies the properties of objects that are preserved through continuous transformations. This shape, despite being so easy to make, has countless fascinating mathematical properties and vast amounts of research dedicated to it. It's called the Möbius strip. So why is the Möbius strip behaving this way? Well, to make some sense of its behavior, let's imagine the strip as two separate rectangles with ends A, B, C, D. When we form a normal loop, we are joining each end onto itself. But when we form a Möbius strip, what we are doing is joining the end A to D and B to C. So when you cut down the middle of the rectangle, and here's the critical part, the top end of one rectangle is now joined to the bottom end of the other rectangle, and vice versa. This is what causes it to remain as a single loop when cut. And what about the 1/3 cut? Well, we can think about it the same way, but with 3 rectangles. You can see how this resulted in the top end linking with the bottom end and forming a loop just like before. But now we also have this middle section which has connected back onto itself and thus has formed another interlinked loop. But the Möbius strip goes beyond these 2 possible cuts. I encourage you to try these out as you get some pretty fascinating results. This is the most beautiful part of the Möbius strip in my opinion. It's an object with endless potential for curiosity and discovery, just like mathematics should be.